Okay, this is Mr. Bletcherty here, and today we're going to be learning about simultaneous equations with a linear and a circle equation. So, what we normally do when we're solving for simultaneous equations is we will label the two equations. So here we go, two equations, 1, 2. Now the top one is clearly the equation of a straight line in the y is mx plus c type format. They don't always come that way, but in this case it does. So that's the equation of a line. Whenever you see the equation where it's x squared plus y squared is something, that's always the equation of a circle. So I'm just going to tell you that's the equation of a circle. Now, to give you a bit of context about where we're going on this, normally when we deal with simultaneous equations of line graphs, where the two lines cross is our simultaneous point or coordinate. Similar kind of story, but now of course we've got a circle and a straight line, so I'm just going to quickly sketch that out so you can kind of see where we're going. Okay, so we'll do sketch. So there's the axes of a graph. So we're going to have a circle and we're going to have a straight line. So the straight line is going to kind of come through there. And the 2 points we're going to be interested in are here and here, and they're the solutions. Okay, so then first step, so it's a slightly different story to when we've got line equations and we were eliminating one of the letters by adding or subtracting the two equations, sometimes after multiplying one or both the equations. Different story here. We're going to solve this by substitution. So what we're going to say is we've got x squared plus y squared is 125. But I know what y is. Y is all of this, 3x minus 25. So that's what I'm going to substitute in where it says y. So I'm going to say we're going to substitute 1, that's equation 1, into equation 2. Okay, that is going to be our first step for our first mark in the exam question. So we will get x squared, so that's the beginning of this equation here, and then we've got plus y squared. Well, y is that stuff. So y is 3x take 25, but I need to square all of y. There you go, I'm squaring all of y, and it equals 125. So the next thing we need to do, well, this is looking a bit busy, so we need to expand that double bracket. So the next step for another mark is expand the double bracket. So when we expand double brackets, we always expand into the boxes. So we've got 3x take 25, 3x take 25. So 3x times 3x is 9x squared. 3x times minus 25 is minus 75x. Same again, so minus 25 times 3x is minus 75x. And minus 25 times minus 25 is plus 625. Okay, normally this would come up in a calculator paper, so you could do that on your calculator. If it comes up on the non-calculator paper, then you are going to use potentially a written method to multiply the numbers, or I don't know, maybe you can do it in your head, who knows. So we need to collect some like terms and simplify. So I'm just going to ring the like terms for collecting. So next step is going to be simplify. So I've got 9x squared minus 75x and minus 75x is minus 150x plus 625. Excellent, another mark. Now, don't forget, we've not really finished this puzzle yet, because we've got to rebuild the equation. Okay, that was only part of the puzzle. So what we had, if we go back up to where we started from, so we've got x squared plus, now we have the double bracket, or the bracket that was squared, the double bracket. Now we've expanded that, so we just need to write all that in. Okay, so we've got x squared plus all of the whatever y squared was, but that equals 125. Okay, so we've rebuilt the equation. Now I need to simplify the equation, and set it to 0, and you'll see why in a second. So simplify and set 0. So we are going to have x squared and 9x squared is 10x squared. Take away 150x. Now I've got 125 here, so I want to take that away from both sides. So now I'm going to have plus 500. Now that is equal to 0. So now this is looking like a quadratic where the number in front of the x squared is more than 1. We've set it to 0, so we're able to solve the quadratic after we have factorised it. So our next step is going to be factorise. So let's see if we can remember how to do this. So because the number in front of the x squared is more than 1, we need to bring these two guys together. So 10 times 500 is 5,000. So what we're looking for is a factor pair that adds to minus 150 and multiplies to 5,000. Now normally I would be telling you to do a factor bug for the 5,000, but that's going to take a long time. Let's just see if we can figure out a quick and easy solution to this. Numbers that add to 150 and multiply to 5,000. How about 50 and 100? Okay, so we've got 50 and 100. Now they multiply to 5,000. They don't add to minus 150, do they? No, so we're going to have to make them both negative. So now they add to minus 150, and of course a negative times a negative gives me a positive. I get 5,000. So we're good. So we've got our factor pair. Now we need to do the shimmy factorising, okay? So we've got 10x squared. Now shimmy factorising is factorising partition. Partition means split up, so we've split our 150x up into minus 50 and minus 100. So let's do minus 100x minus 50x. We've still got the plus 500, and it all still equals 0. And then we need the shimmy thing in there. So now we need to factorise number out, letter out, so we can take the 10 out and x out. What's going to be left? That's going to be x in here. Take 10. Now if we've done that right, of course we can copy that back up here. It's still going to equal 0. So the question is, what goes in here? So something times x is minus 50. It's going to be minus 50, isn't it? Minus 50 times minus 10 gives me positive 500. So that all works out. Now I need to collect that all up. So I've got 10x minus 50 lots of x minus 10. So 10x minus 50 lots of x minus 10 still equals 0. So now we need to solve. So that means, of course, well, I want the answer to be 0. So if either of the brackets is 0, we are good. So that one's pretty simple. So I'm about to fall off the bottom of my paper. So that is going to be x is equal to 10, because 10 minus 10 is 0. And out this way, I'm going to have 10x minus 50 is going to give me 0. So of course, if I add the 50 to both sides, then 10x is 50. Divide through by 10 both sides, x is going to equal 5. Okay, so we've got an answer for x here and an answer for x here. So we've got 2 answers for x. Now let's just remember what we're trying to get to here. I need 2 coordinates. So I've got the 2 x bits of the 2 coordinates. Now I need the 2 y bits of the 2 coordinates. And for that, we need to substitute. So we're going to substitute back in to the line equation. So substitute line equation 1. Let's always substitute back into the line equation. And I don't want to get confused. I need to do this in kind of 2 batches, because I don't want to mix and match my x's and my y's, because that will go very badly wrong. So let me remind myself what we're doing. So y is 3x minus 25. So y is 3, x is 5 minus 25. And over here, y is 3 lots of x, which is 10 over here, minus 25. So that equals 15 take away 25, which means that y is minus 10. And here, this is going to be 30 take away 25, which means that y is going to equal 5. So the last part then is the answer. So they are the coordinates. Just going to make sure I don't fall off the paper entirely. Coordinates. Okay, let's just box that up. And let's just also remember what we're doing. That's a y value, that's a y value. And the coordinates are going to be that one and that one. And let's remember that x and y are the coordinate values. Let's not get confused. And there are 2 solutions. Let's put an and in there. Right, so I've got x is 5. Matches up to the y is minus 10, and the x is 10 matches up to the 5. And that is how we solve 2 simultaneous equations when one of them is a line and one of them is a circle.